I'm Valentina. I'm 14 years old, and I want to help humans explore outer space. We talk about building cities on Mars and exploring beyond our solar system, but there's an invisible barrier standing in our way. It isn't just about the rocket, fuel, or distance, it's radiation. To exit our solar system, we first have to solve the problem of keeping humans alive in space and other planets. Right now, I don't have a lab or a company, but I have a theory that could change everything. On Earth, we are protected. Our atmosphere and magnetic field act as a natural shield. But once we leave low Earth orbit, astronauts are hit by galactic cosmic rays, or GCRs. But those aren't just rays. No, they're HZE nuclei, high-speed, heavy ions that act like subatomic cannonballs. They are so powerful that they can cut right through the metal hull of a ship when they hit a standard aluminum hull. Oof, they shatter the atoms, creating a secondary spray of neutrons that is even more dangerous for the crew. One estimate from NASA suggests that 1/3 of an astronaut's DNA would be cut by these rays every single year. This can cause cancer, central nervous system damage, and acute radiation sickness. Not good. The traditional solution is passive shielding. Basically, just making the ship's walls thicker. But a mission to Mars using traditional shielding would require 9 massive SLS rocket launches. 9! Just to get the protection into orbit. That is incredibly expensive and heavy. My theory is that we don't need thicker walls. We need a better atmosphere for the rocket itself. My idea is based on a concept called mini magnospheric plasma propulsion, M2P2. Instead of tons of lead or metal, we use a compact magnet, no bigger than a desk, and inject a low-energy plasma, like argon gas, in space. Magnetic fields can get frozen into plasma. As the plasma expands, it stretches in the magnetic field with it, inflating a massive magnetic bubble that can extend for kilometers around the ship. This bubble mimics Earth's own magnosphere, deflecting GeV-level particles before they even touch the ship. While this is currently a theoretical model, the math is promising. Power. A multi-unit system would require about 100 kilowatts, roughly what the ISS generates today. Efficiency. We could achieve the same protection as those 9 SLS launches with just 2 launches. By pulsing the shield, we can maintain the bubble without pushing the ship off its course. Of course, 1 layer isn't enough. My vision for the future uses a system of systems. We combine the magnetic bubble with hydrogen-rich holes, like subcooled solid hydrogen, which is the most mass-efficient material for stopping radiation. During solar storms, astronauts would also wear the astrorad vests, which were recently tested on the Artemis 1 mission and proved that they could reduce radiation doses to vital organs by up to 60%. I'm only 14, and right now, this is just an idea. But every great mission in history started as a theory, and then it became a reality. I believe that if we can solve the radiation hurdle, there is no limit to where humanity can go. I'm building the roadmap today so that we can reach the stars tomorrow. Join me on this journey.